Ever wondered where stars come from and where they go when they die? This cosmic journey starts within galaxies, where nebulous clouds of dust and gas lie. These are the celestial cradles we call nebulae. Within these nebulae, gravity plays a pivotal role. It pulls together the dust and gas, causing it to collapse into a dense core. This core, or what we call a protostar, is the first step towards the birth of a star. As the protostar continues to pull in more mass from its surrounding nebula, it grows denser and hotter. This core becomes so hot and dense that it sparks nuclear fusion. This fusion is essentially the ignition of our star, marking its birth. It's a process that transforms simple elements into complex ones, and in doing so, creates the light that we see shining from millions of miles away. Stars, like people, have their own life story, starting from a simple cloud of dust and gas. This is the point where a star truly shines, but how does it happen? Let's dive in. A star, much like a human, goes through a life cycle. Its most vibrant phase is known as the main sequence, where it spends the majority of its life. During this period, it's a bustling factory of energy, burning hydrogen to produce helium. This process, called nuclear fusion, releases vast amounts of light and heat, making the star shine brightly. Now you might wonder, are all stars the same? Well, not exactly. The size, color, and lifespan of a star during this stage are greatly influenced by its initial mass. Larger stars are hotter, brighter, and live fast-paced, shorter lives. It's like a cosmic dance, where each star performs according to its mass. The heavier ones, with their intense heat and light, steal the show, but their performance is fleeting. So a star's brilliance in its prime is dictated by its initial mass. Larger the mass, brighter and shorter the life. What happens when a star exhausts its nuclear fuel? This is a question that has fascinated astronomers and dreamers alike for centuries. The answer, it turns out, depends on the size of the star. Let's start with the small to medium-sized stars like our very own Sun. When these stars run out of fuel, their core contracts and their outer layers expand and cool, transforming them into red giants. It's a bit like a celestial balloon inflating. This phase, however, is short-lived. The outer layers of the red giant are eventually expelled, creating a planetary nebula, a beautiful glowing shell of gas and dust. What remains of the star shrinks down to a dense, hot core called a white dwarf. These white dwarfs will continue to cool and fade over billions of years, becoming black dwarfs, the final, quiet resting place of stars like our Sun. For larger stars, the end is much more dramatic. These stars have enough mass to undergo a supernova explosion. It's a celestial spectacle like no other. The star's core collapses, and the outer layers are blown off in a powerful explosion. This explosion can outshine an entire galaxy for a brief moment. What's left behind depends on the mass of the original star. If it was large enough, it could leave behind a neutron star, a super-dense object that's about the size of a city, but with the mass of about 1.5 times our Sun. If the star was even more massive, it could collapse into a black hole, an object so dense that not even light can escape its gravitational pull. So, there you have it. The life cycle of a star is a journey of transformation and change, of growth and decay. From their birth in a cloud of gas and dust, through their radiant prime to their ultimate demise, stars are a testament to the grandeur and dynamism of the universe. So depending on their size, stars either go out with a whimper or a bang. Stars, they're born, they shine, and they die. But their story doesn't end there. Our journey today has taken us through the captivating life cycle of stars within a galaxy. We've seen how stars begin their existence in the cradle of cosmic nurseries, nebulae, and how they shine brightly during their Middle Ages, providing light and warmth to surrounding planets. We've witnessed the dramatic end of stars, either in a serene fade-out or a supernova explosion. Yet, even in death, stars play a crucial role in the cosmos. The remnants of dead stars become part of new nebulae, seeding the universe with elements necessary for the birth of new stars. This continuous cycle of stellar evolution from birth to death and rebirth is a testament to the dynamic nature of our universe. Each star has its own unique journey, from nebula to neutron star or black hole, contributing to the ever-evolving universe.